All right, our next contestant, Sean Fruin, coming in to talk to us a little bit about his workflows and the work that he's doing in mechanical, electrical, and plumbing.
How many engineers? How many engineers do we have here? 1 engineer? 2 engineers? 4, 5? Okay. It's not a lot. It's all right. All you architects can see the cool stuff we can do, I guess, to make your lives easier as well.
You ready?
Yeah, now you can introduce it.
All right, so Sean is, if you didn't hear already, a mechanical engineer. And he just recently, he's an innovator and lover of all things Dynamo. And in fact, he loves it so much that he started a company, Sigma AEC, to put some of these practices out in the world.
We like to think that we're making BIM superheroes. So.
Exciting stuff.
Yeah.
All right.
Thank you. Thanks. All right, so everyone ready for Dynamo algorithms for MEP? Awesome, let's do this. All right, here's the ugly truth about Revit, right? We start with a relatively blank model, and we click and drag our way all the way to a complex BIM model, right? I mean, this is tens and thousands of clicks, tons of places for error. There's got to be a better, smarter way. I absolutely hated my job as a young engineer, marking up red lines, placing every diffuser, and especially line up to ceiling grids. So at a young age, I started BMXing, and I really learned the power of continuous improvement. So we built these over time. I then got into the culinary arts under a Johnson & Wales chef's Vito, and he really taught me about like process and how to do things right. And then all this got reinforced when I got into the manufacturing industry. Here they're doing crazy Excel sheets to let data flow. Then I got into the AEC industry, and I was shocked, right? Just train trace papers on our desk, data everywhere, markups, just it wasn't right. So I discovered Dynamo, right? And then I realized like I had to be the fish out of water. I had to go against the norm and start using Dynamo as a design tool. So this whole workflow started off with Excel, trying to get Excel data into Revit. I was pretty good at Excel. But then it bloomed into this whole other stuff. So I started using all the math that I learned in college, 3D calculus, matrices. And now we're even starting to do things with like optimization. So just days became fun again. Now with project setup is our first pain point. So let's hop into it, right? So project setup, we had this huge project that literally took a week to set up. And not a regular week, like a 50-hour week. One night was just spent dragging views onto sheets. Like all night. I missed a company softball game. I was very disappointed. So I said, no more, right? We can do this all with Dynamo. So here's that workflow. So we can use some data shape nodes to bring in the link model. We can copy stuff from the architecture model, scope boxes, match lines, our rooms, just everything possible. We can then make all of our sheets and views and just place them nice and organized. One button, job setup's done. A week down to a button. Pretty incredible. So the next step for a mechanical engineer is to start to get some information about the spaces, right? So the pain right now is you have to go through every single space and find the space type. No fun. And then geometry, right? So geometry comes in at the 8-foot level, and you have to go in, cut section boxes. That's no fun. So we can automate all this, right? So we're going to take the architecture link model. We're going to purge some data from the spaces and their location, or the rooms, and make our own spaces using the ray bounce node, shooting some lasers up top. And now we have our right volumes and everything to do calculations. We can then use fuzzy logic to match up weird architects' names that we get for spaces to our best matching space. Once we have all this data, like we have the power at our fingertips now to automate all of our engineering calculations. We can even do pressure drop relationships. So all engineering at this point can pretty much be automated. At that point, we have this just wealth of information about spaces to do other stuff. So, of course, engineers don't trust algorithms, I've come to find out. They want to do it themselves. But with Dynamo, of course, we can push all this to a dashboard and start to see whatever we want, right? Do a QA/QC check. We can also do a QA/QC check just with native Revit now that we have all this information. So, like, if a window loads there and it's purple, forget about it. So then I was cruising, right? I'm feeling confident, and I decided to take on the challenge of zoning a building. This was like the next step. And I ran into a huge problem. it's really easy for a human to kind of see clusters of spaces, but really hard for the computer. And this led me to a late night Google search on unsupervised machine learning. And this stuff isn't complicated. You all know it. Like, decision tree is unsupervised machine learning. Line of best fit is unsupervised machine learning. The coolest one I found, the one that we implemented to finish the zoning, is k-means, where we give a set of points and we're able to group all these points together based on geometry. So here's our zoning algorithm then. We then do the decision tree to group our spaces based on attributes. We can then go into k-means to find the clusters of those groups to zone our building. We can then start to do things too, like decide how many air handling units we need, how many exhaust fans we need, how many chillers. Now here's where it gets really exciting. We have the new Revit systems analysis. So we've developed some nodes to build the Revit systems analysis, which can give us an energy model just really easily, way better than going to train trace. We can then set all the 3D elements. We can start to put data into our schedules, and we can even make one-line diagrams with Dynamo. You can sketch with Dynamo, I guess. So all this comes down to computational design. That's how we're doing all this crazy magic stuff, right? And it all really comes down to taking geometry and either building it up or deconstructing it. So we can take a space and just find the surfaces. We can also align the ceiling, and this, of course, could help in everyday work. We can make sure on a Friday afternoon, those diffusers are to the ceiling grid. We can make sure that the toilets lined up, or the diffusers lined up to the toilet. We can place hangers. And my favorite, we can go ahead and make sure that those diffusers are lined up in the ceiling grid. No more late Friday afternoons. But let's take this a step further and start thinking about generative design for MEP. So here we have the problem of diffusers. So manufacturing data comes in, and you have to calculate based on the CFM, and it just becomes kind of a mess. So we can have Project Refinery run through all that, build a fitness function to find the best, taking cost, noise criteria, and coverage all into effect, and then find the best. And we're not just placing this stuff either. We're also putting all the data into the project. And this lets us build relationships. So there's this idea of a relational database where you have these primary and secondary keys. This lets us connect our 2D schematics even to our 3D elements. Are we able to group up systems? So that's what we're doing here with our last example, is taking all the diffusers on a VAV system, finding the main, and then building a parametric model to start that beats the Revit auto routing that they have. Of course, we can then evaluate the design using Project Refinery and then use the native tools. So here's my challenge to everybody. You can either stick with Revit and do things the way that it's always been done, and just your career comes to a halt, life's not very fun. Or you can take on the challenge of learning Dynamo, and your life becomes a lot more fun, more creative thinking, and I'll show you how far this rabbit hole can go. Thank you.
Life advice from Sean Fruin. All right.